Okay, people, 6.5 properties of logarithms. So we've dealt with what's a log, what does it look like on a graph, how to use it to help us solve an equation, and now we're going to talk about specific properties of logs. I like to think of this as two things, expanding logs and condensing logs. It's a two-way street, it's a back and forth process, and you're going to want to have them expanded sometimes to help you with certain things, and you want them condensed in other times to help you with certain things. So we need to know how to switch between the two. What's in this box right here, this concept box, are the properties. We're going to talk about them, and in example one, we're going to prove one. But after that, these are properties. These are proven things that you are allowed to use. You never need to prove them again. They are just fact. You can use them whenever it is convenient for you or whenever it helps you. And what I really want to draw your attention to is that they're very similar to properties of exponents. Okay, properties of logs and properties of exponents. Now, if you are taking notes on your own paper, this box absolutely needs to get copied in. You need your 3 log properties. So I would pause, write it down, and then continue, and then we'll talk about them a little bit. Okay, so as you can see, the product property of logs. If you have a log of a certain base of 2 things that are multiplied together, that is the same as taking the log of one and adding it to the log of the other. Very similar to properties of exponents, right? If you multiply things with the same base, you can add their exponents. Very similar. The quotient property, if you have a log of some base with something divided by something else, that is the same as saying the log of that base of one minus the log of the base of the other. And notice the numerator comes first and the denominator is always after the subtraction. And then the power property is if you have the log of some base of something raised to a power, that is the same as sliding the exponent in front as a coefficient and timesing it by the log base of the other thing. Okay, so again, these are properties you can use at your disposal. All right, let's actually prove one of the properties. And this is more so just to give you an idea of that it doesn't come out of thin air. This is nothing you'll ever need to replicate, but it's just good to know. Okay, so we're going to prove the product property of logs. So we need to let x is going to equal the log base b of m, and then y is going to equal the log base b of n. Now, in order to prove this, it's going to be a lot easier if we think of these things along the lines of exponentials. So remember, right? In order to convert this to an exponential, b stays our base. B to what power? Because remember, a log is an exponent. So this is our exponent. So b to what power gives us our result? So b to the x equals m. And the same idea here. The base stays the base. We're going to convert b to what power, because the log is an exponent, gets us to our result. So b to the y equals n. Okay, now we are going to prove the product property here. So now we have b and m. All right, so let's make it a product. So we're going to do our product property. All right, so we're going to multiply b to the x times b to the y. And since b to the x equals m and b to the y equals n, then b to the x times b to the y is the same as m times n. Okay, now this is where our properties of exponents comes in. When you have the same base, we multiply things by the same base. What do? We add their exponents. So x plus y, and that's just equal to, again, m times n. Now, if we want to get to the point where we undo this base, we want to take, so this was properties of exponents. Now we want to take the log base b of both sides. So we're going to take the log base b of b to the x plus y and the log base b of m times n. What happens when base, log, and exponential are the same? So we get x plus y equals the log base b of m times n. And then let's go back to the start. Remember, guys, what was x? Up here, x was log base b of m, and y was log base b of n. And that is equal to log base b of m times n. And look at that. That is exactly, I mean, aside from the fact that the sides of the equation are just flip-flopped, this is exactly our exponent's property. Our logarithm's property. If you take the log of the same base of two different things and you add them, it's the same as taking the log of that base of their product. So just a little way to kind of show you, again, not something you'll need to replicate. Give it a shot in the try it problem, but it's really just trying to help us think about how these properties, where really the properties come from, and that there's kind of a strong connection between these properties and properties of exponents.